Welcome to the Ex Terra Podcast. The Ex Terra mission is to explore and discuss the business of space and its effect on the national and global economy, as well as life on Earth. How does what happens in space affect your life every day? That's what we're exploring on the Ex Terra website, as well as on this podcast. On this edition of the Ex Terra Podcast, we continue our conversation with Simon Drake, President and CEO of the Space Commodities Exchange. Simon, welcome back to the program.
Great to be here.
Let's start with asteroid mining, because there's been a lot of focus on asteroids. NASA made a lot of big deals about visiting asteroids. They've been to Bennu, and they're about to return a sample back from that mission. So what are the challenges that are associated with asteroid mining?
Distance.
In a word.
Yeah, just one word. All right, let's add another word: time and distance. The time and distance to get out to where a majority of the asteroids are, and find the right ones, have the time, the equipment can extract the materials we want, and return back to where the marketplace is. So, for example, my theory on asteroid mining, and this is my theory, and people will shoot me down, but it doesn't matter, is that in our nearest hope, and I speak of this in my lifetime, you know, our grandchildren will have a lot more fun than we will when it comes to asteroid mining, is that a asteroid that comes close to Earth, and this might mean, you know, from the distance from the Earth to the Moon times 10,
right?
which is not that close at all. Anyway, so an asteroid that comes close enough and is of a substance that doesn't dissolve on its way into our proximity, that we can plot successfully, go to, and my business case is suck all the water out of it, and then eject from it and intersect back into an orbit between the Earth and the Moon, or somewhere near there. So that way you've got a successful extraction of resources from a visiting asteroid or comet, where the commodities resources can find a use for us. So that is my business case of what I would like to see in my lifetime. Now, getting back to where we are in reality now, it's a bit different, because, you know, missions to asteroids, you know, they are just so completely insanely, from an engineering point of view and a navigation point of view, complex.
Right.
And you know, you can't say, oh yeah, we're there, we are there. Yeah, it's all possible, because there's so many more missions need to be undertaken to refine the process of getting onto an asteroid and actually extracting something from it, rather than a few grains.
Do you envision there would ever be a time that they could go find the asteroid, lock onto it, drag it closer, and do the actual mining where it's not, we're transporting the actual material? Or is it, let's put it this way, is it harder to transport the actual asteroid or extract the materials there and transport them back?
From a physics point of view, I think it's just harder to stop it.
Okay. Would take some energy, wouldn't it?
Yeah. Okay. Or you know, or to latch on to it, and to enact that process of latching on to a very fast moving object, and the density might be something, you know, rock hard frozen, or it might be like, you know, one of those slush puppy ice cream, you know, with gravel on top, you know. And if your goal is water, then you've got to somehow stay on it, bring your energy with you, kick in the process of extracting, you know, hydrogen, oxygen. And as you can imagine, from an engineering point of view, not much of this has been invented that is capable of going out that far and completing that mission. The other side of asteroid mining, which I think excites the journalists, is that we will bring back a gold-sized meteorite the size of Manhattan or something, and everyone will be, happy. Well, it won't work that way because it won't happen in our lifetime anyway, because it would just take so much mass to move it, and then you got to melt it. And if it was a precious metal, and I'm a precious metal fan, that would completely degrade the price of precious metals.
Sure. Dump all that into the market and the price goes down.
Yeah. Now I have nothing against where everyone can carry gold coins around in their pocket. It's just that it'll take one gold coin to buy a liter of milk.
Yeah.
So whether this happens in 1,000 years, I don't know. Where all I know is when it comes to the business models of asteroid mining, there are a few business models that I've come across that are interesting, but from a technology point of view, it is still way out there, and it's still worth investigating as well. It's not something that I'd write off and say, oh, we should just mine the moon, or something like that. I've found that there's two camps. There's the lunar resources camp, and then there's the asteroid mining camp, and you don't want to be in between them. And it's like trying to break up a fight between two dogs. No, I'm joking, but you get the picture.
Well, the moon obviously is a lot closer.
Yeah, and
it makes things a lot easier.
Yeah, it does. It does. And with the lunar surface, even with the lunar surface, and I'm also a CEO of a company called the Lunar Resources Registry, where we are making a resources map of the moon and working out how to register the right for companies to explore and extract resources within the guidelines of space law. You can't own anything on the moon. So in this journey down the lunar resources rabbit hole, there goes Alice. Everything is upside down, back to front, from the extraction technology to the opinions on where the resources are and what is of value. You have helium-3, you have silica, you have my favorite is the nickel deposits from old meteorites that are strewn around craters. Yeah, you can really go into this world of exploration on just of the subject of what is of value, what will be of value in 5 years, 10 years, 20 years,
So what's some of the history of what we've already done on the moon as far as any kind of a commercial effort is concerned? It's all been exploration up to this point, I'm sure, but there are a lot of things that we've learned over that will be able to help in getting the lunar commerce thing going.
Yeah, I'll go back a bit to how has the lunar exploration helped us commercially, and I'm going to jump over to the USSR, and I was at a museum in St. Petersburg, and I was looking at a lunar rover. And I thought, those Russian scientists must have had, a very interesting time building a lunar rover back in the 70s, before I was born. So even back then, the concept of lunar operations was supporting the sciences, building information, building careers. Go over to the US side, you think of the aerospace companies that pitched in to become space companies or build space technology. So that's kind of my starting point of the lunar operations have done great things for building industries. And where are we now is we have been at a stalemate where exploration dropped off. It was picked up by the Chinese. Now, I'm not saying that it completely dropped off in terms of boots in the regolith, because along the way we've had India, the US, Japanese, of course the Russians, forgive me if I'm forgetting anybody else, doing lunar reconnaissance, which is all about mapping the surface and trying to find out what's there and how to extract it or how to appreciate it.
So what are some of the primary resources the moon can offer?
This depends on who you talk to.
Okay.
Yeah.
So many things are, it depends.
Yeah. Okay. Let's look at the top of the pyramid in terms of what can you go to the moon for and bring back to Earth that has value. And I think the number one thing that I've heard a lot is helium-3. Now, I haven't taken the time out to work out how the helium-3 extraction process works. You know, there is some knowledge of where to look for it, but how to extract it from regolith, that is another subject. So then you go down and you say, okay, well, what are the secondary resources that might have value on Earth? And you could look at all the, like platinum group metals, and I'm sure the geologists could chip in here. You have all, the expensive to extract metals on Earth. If you can refine them from regolith and bring them back to Earth, then there's an equilibrium somewhere. For example, I always like to say, why make an open cut mine in the jungle in search of, rare earth metals that we use in our smartphones when you can extract them from the lunar surface and not have any environmental damage? So that's just two things: helium-3, platinum group metals, rare earth metals. Then you go back to, now we come down to in situ resource utilization, which is using resources on the lunar surface, or extracting them from the lunar surface for use on the lunar surface, like extracting iron and 3D printing structure, or using silicate and extracting silver and building solar panels. So there's different ways you can look at lunar resources, and it comes back to the use. Do you want to cater to a market based on Earth, or do you want to cater to a technology demand on the lunar surface? For example, a space agency can say, we want to build a habitat, and we want to print it from regolith, and we want to 3D print components. Well, therefore, a lot of those components will have to be made of aluminium or iron or some mixture. And there's been a lot of work by scientists and enthusiasts on what technology is required in order to extract certain elements from a regolith to 3D print these things.
So where are the strategic opportunities then for lunar mining?
To be the first.
Okay.
Yeah, I think the strategic opportunity right now, and this has fueled the decision of my partners and I to make a spin-off company, the Lunar Resources Registry, is finding out exactly where the resources are and trying to put a value on it. In the same way that a mining company spends, on average, I think mining companies spend like 10% of their budget on research and development, which is finding new sites, finding new areas, and looking at a deposit and inferring a value. At the moment, that to me is the strategic value in terms of lunar resources. The next thing will be able to have the technology that goes to an area and confirm what resources are actually there.
Right. And that was the next question, because when you look at a gold miner, they go out and they drill test holes and they find out how much gold is there. How do you determine what's there when you're not there?
Well, one way to do it is you blow off the dust off the Apollo technology missions and do it all again.
Sure.
And another way is that you find space startups with passionate teams, engineers, graduates, you name it, all the STEMs and the visionaries who say, you know what, we can actually do it cheaper than an Apollo mission. We can do it remote. We can do it with rovers. We can do it with drills. Now, saying this is quite easy. When I look at the next ESA mission to drill into an icy crater in the South Pole, and they even have designed an ice drill for it. it is such an extensive operation within itself. And this is just to look for water. And so we're not ready to let loose fleets of rovers with drills and sensors and hyperspectral cameras onto the lunar surface. That's still coming. And I think what's holding that back is the lack of knowledge about the payoff, because we don't know enough about the lunar surface.
Right.
A lot of people, from an investing point of view, would say, well, it's not really going to work out, So back to your question about strategic, I think the biggest strategic thing to do right now is to work out exactly what is of value on the lunar surface.
Right.
And we're not there yet. I mean, there's different things you can point your finger at, and which is probably good. But we're working on it, and I think that's half the chase anyway.
You're listening to the Ex Terra Podcast. I'm Tom Patton, and we're talking with Simon Drake, President and CEO of the Space Commodities Exchange. And Simon, how realistic really is the concept of extracting resources from the moon, short-term and long-term?
Short-term, when we look at our space resources due diligence, and we did this, I'm the co-founder and managing director of a company called Space Ventures Investors. We had a lot of potential investors and investors asking about asteroid mining space resources. So naturally, we looked at the lunar surface, we looked at the supply chain of the lunar surface, we looked at what's available. I think short-term, it is about sifting through regolith and using the low, gravity 1/6 of Earth in order to sift through that regolith and start parting it, segmenting it, and then using what small portions of it that we want. Let's say we can find the iron particles, or the titanium, or you get the picture. I think in the short term that is the best that we can do and we should be doing.
Right.
Long term, you get into different things like, okay, get the regolith, bake it, heat it up, suck the oxygen out, melt the iron out, what's left over, turn it into bricks. That kind of operation might be 10 years away. The next thing is what I call going after the gold, is trying to find out where the high value targets are on the lunar surface. And that involves a different mining technology altogether. It might mean taking terrestrial equipment and putting it on the surface of the moon to go for high value targets. And even then, that still might be the process of sifting through regolith. And this all comes back to, the geology of the Earth is completely different than that of the moon. The Earth had these phases where it was warmed up, cooled down, warmed up, cooled down. Water went through, water comes out. The moon was, pretty much formed from the same substance as the Earth, and then just got bashed for billions of years. So it's just been pulverized. The surface is pulverized and pulverized and pulverized. Yeah. So from a precious metals point of view, I say, well, where was the last pulverized meteorite location where it wasn't pulverized that much? So it wasn't like completely like
just a glancing blow.
Yeah, there's some fragments around, but now we're into conjecture, because other people, geologists will say, well, no, on Earth this is how it's done, and a senologist, which is the equivalent of on the lunar for the moon, will say, well, no, this is what you'll be doing. But you know what? It makes for an exciting stimulation of conversations about how to tackle a subject. And that is what is also quite elusive about the whole field of space resources is, well, how do you actually go about it? It's not like you're going into a great inland freshwater lake, right, just to get fresh water and some cute fish.
In some of your materials online, you focus a lot on the moon's craters. Why are the craters on the moon so important?
I think it's a personal favorite of mine because when I started looking at it, I looked at it from an investor point of view, and it might be a bit immature to say, what excites people? Well, what excited people about the US and Australia was gold rushes.
Right.
And that brought in a lot of people. They said, well, this is what we're going for. And, of course, the old story always rings true. The guy who made the most money in the gold rush was the guy selling the shovels. So,
right.
And then when I think, oh, well, I'm looking for, precious metals on the lunar surface as a side thing in our overall businesses, I think of Mark Twain's quote, a gold mine is a hole in the ground with a liar at the top. So when I go on this path of saying, well, let's look at the craters, I'm ready for the criticism, but I still think it's plausible that there are high value craters. And when we started with the Lunar Resources Registry and we looked at the data of looking at the topography where you could see a crater and the iron content or the gravitational anomalies, you can clearly see that with a lot of craters, there's something that has been deposited there.
Mm-hmm.
It's still there. It hasn't been, completely pulverized yet. And to me, it's like, well, with the lunar surface, you've got to start with a thesis, or multiple theses. You just can't say, oh, it'll work out. No, it won't work out. You actually need to say, well, here's a location. It's a crater, it's a kilometer wide. You can measure the impact size. You can estimate what hit it. Maybe you can estimate the inclination. Maybe you can estimate the mass. You can see that there is gravitational anomalies. There is something metallic there. It's not all just, regolith. Therefore, something is there. And this to me is where we're at now. And it's kind of backed up because you look at the missions of the Chinese, and they are really putting a lot of effort into this.
So how does that compare with the mare, the craters versus the mare?
The mare is, from what I can tell, it's more of an even, flattish surface. Left over from the lava, high in iron. So I would assume that is a more of an area for in situ resource utilization, extraction of iron as one example, that you can then for transport and build a structure. So if you look at a situation like that, you could say, well, maybe the first structure to be built on the lunar surface will be built where the materials are most in abundance and easiest to get to. In contrast to the Mare, a crater, it's incredibly difficult to go down.
Right.
If you look at the concept of a moon rover, 4 wheels or 4 legs or 8 legs, 8 wheels, how much clearance between the surface and the chassis. Right. To go into a crater and stumble over, go down an incline, whether it's like that or like that.
Right.
You're in a different world of engineering. So back to the Mare, it's probably a good location to start a first installation based on extracting what's there, given the least possible points of pain.
I find it interesting that you talk a lot about iron, which people don't think about iron as being a particularly exotic metal. You think about the space program, you think about, I would say aluminum, you'd say aluminum or titanium or, something of that nature. And here you're talking about regular old iron. What are some of the, I'm trying to think of a way to phrase this question. But how do you take that iron and turn it into something that's usable on the lunar surface that people don't think about their cast iron skillet?
it will probably have to be extracting iron or aluminium, titanium. Let's go through them all. Okay. And heating them to their melting point, and then first thing is making something cast, and then 3D printing from that. And I choose iron because from iron you can make real structures.
Right.
You can make a skyscraper, if you have enough iron. You can make something that can withstand a small, meteorite hit. That's just one example. Yeah, I just look at it from a construction point of view.
Is there enough gravity on the moon? Because as most people are aware, these processes know that it's not just heating it up, but there's got to be a way for the metal that you want to fall out of the material that you don't. And that requires gravity. Is there enough gravity on the moon to do that efficiently?
I'm not qualified to to say yes or no, but there is gravity, and that is the most hopeful thing about the lunar surface, is that it's our closest planet. As I was talking earlier, asteroids are a bit too out there. The moon, for all of its negatives, it has a lunar night, lunar day, massive temperature swings. At least it has gravity. And if you look at it from that perspective and design mining equipment to say, look, we've only got 1/6 gravity, but it's better than nothing.
Right.
Therefore, you can factor that in and say, okay, maybe the heating process is going to be, you have to heat something for longer to let it, fall through or coagulate. I look at it as the low gravity as a positive, because if you, it's a positive element that has to be incorporated into any resource extraction.
But then that heating also takes a lot of power. What do you envision as being the power source to be able to heat the material to extract the resources?
Two main contenders for power source is the good old faithful nuclear, and then the other one is solar. And by solar, I mean if you had a massive solar field that was able to direct energy to one source that was then used to, melt metal, which is quite an achievement in itself. It's the same with nuclear. You'd need multiple kind of nuclear power sources in order to do that. And I think one company has already invented a nuclear power source that can work on the lunar surface. Those are the two main power sources that I think of when I'm planning of how do you build a business model.
Well, Simon, it's been another fascinating conversation. We'll pick up with another one in just a little bit, but I want to remind folks that we have been listening to the Ex Terra Podcast. We've been talking with Simon Drake, President and CEO of the Space Commodities Exchange, and this has been the second of our 4 conversations that we'll be having with Simon. Next time, we'll explore the concept of the Lunar Resources Registry. And that's going to do it for this edition of the Ex Terra Podcast. Find us on the web at xterrajsc.com. And be sure to connect with us on LinkedIn and follow us on Twitter at XTerraJSC. Until next time, I'm Tom Patton. Thanks for listening.